Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Diah Ayu Thyrta Istiqomah Joko. I'm from Chemistry A. Now I wanna summary about three video. The first video is analysis of water and wastewater. To ensure and determine the quality of water, it is necessary to carry out chemical and physical analysis. Sampling strategy is a method that must be ensured that the sampled water does not change between the time of taking it until it is analyzed, so that the data is called valid or accurate. Sampling is divided into three steps. The first step is representative sampling. The second step is transport and preservation samples. The third step is chemical analysis of samples. Sampling preparation. First, the bottle that will be used to take the sample must be clean and has been rinsed with distilled water. Then proceed with the liquid that will be used to fill the water and dry. The second preparation is the same applies to sampling equipment, such as pipes, pumps, and must be clean and free from residues and traces of old samples, especially mold and mildew. The third is contamination from metals or sampling equipment that can dissolve the sample must be prevented. The fourth preparation is samples can be taken separately using a bucket, plastic bottle, or glass tied with a rope, and then put into rivers, canals, wells, and so on. Take a sample at a certain depth. The first step to take a sample at a certain depth is provide a closed bottle that can be opened when it reaches the desired depth. The second is another way to use a kind of suction pump. The third is samples from faucets can be taken with a bigger glass. Automatic sample is a special tool for consecutive sampling. Consists of a suction pipe at a certain depth, pump, clock to control sampling frequency, a tool for dividing samples into vials for mixed samples, and isothermic box containing bottles of mixed samples with cooling by ordinary or dry ice, so that sample preservation can be carried out no later than 1 day before being brought to the laboratory. Disturbances that may arise during the storage and transport of samples. First is gases such as O2 and CO2 can be absorbed by the sample water or can disappear for sample water into the air. Second is suspended and colloidal substance can form their own flock and precipitate so that the samples becomes different from the state when it was taken. The third is some solutes. Some solutes can be oxidized by dissolved oxygen so that they turn into ionic compounds. That's all from the first video. The second video I wanna summary is about analyte contamination. Contamination is defined as the entry of unwanted compounds into the sample during the sample pre-treatment process and during analysis. Sources of contamination in samples can be from atmosphere, operator, equipment, water, and reagents. Contamination from the atmosphere, mainly from trace elements, particulate on the soil surface, and suspended material in the atmosphere. The simplest way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. Contamination. The first is contamination by operator. The analyzer can be a source of contamination to the sample to be analyzed either through direct contact or through the air. NaCl can be transferred to the sample through the operator's breath. Dust and cigarette smokes are sources of metal contaminants. Powder, lotion, perfume are sources of contamination. Human skin is reported to contain some very low concentration of metals. Masks, gloves, coats usually used to reduce analyte contamination. The second is contamination from equipment. First is glassware. Glass in analytical chemistry means borosilicate glass, such as Pyrex, unless otherwise specified. Contamination of the sample from the glass is usually caused by a take of the solution container. Pyrex is resistant to weak acids and bases but less resistant to strong acids than bases. For the analysis of silicon, boron, aluminum, natrium, and calcium should not use Pyrex bottles. High silicate glass is more resistant to solution and heat attack, up to 90-100 Celsius. Washing glassware using a 1-1 mix. Washing glassware using a 1-1 mixture of concentrated H2SO4 and HNO3 is better than a mixture of Cr2O7 and H2SO4. To keep glass contamination to a minimum, equipment should always be stored and immersed in a dilute solution of HCl or HNO3 when not in use. Hot HCl or HNO3 can be used to clean metal surface of glass. Other preparation equipment that is frequently used and has a lower probability of metal contamination. The first is fused silica or quartz. Can be used at high temperatures and is safer from metal contamination. The possibility of contamination comes from materials that are absorbed by silica in previous uses. It is recommended to keep washing using HCl and HNO3 in order to reduce the amount of contamination in the previous measurement. The second is plastic, or polyethylene and polypropylene. Plastic are resistant to attacks by most of the reagents used and can stand the heat and contains additives such as antioxidizer, UV absorber, and other compounds to assist mixing and fabrication. The third is Teflon or tetrafluoroethylene polymer. Teflon can be used for temperatures up to 300 Celsius and inert to almost all analytical reagents. The fourth is PVC or polyvinyl chloride. PVC contains metals with high enough level. The example is Zn 7 ppm, Fe 270 ppm, and also report to contain plumb. Most plastics are contaminated with polymers such as zinc stearate on the surface, so they need to be cleaned before use. The 5 is rubber. It is recommended not to use rubber equipment in the trace analysis. Rubber contains several additives such as zinc oxide, a compound of Pb. The last is filter paper. Most filter papers contain a number of metals with fairly variable composition. The last contamination is contamination from solvents or water. Because water is used in very large quantities compared to the reagents. Ratio is 100 times compared to the other reagents. It is necessary to pay special attention to the purity of the water used, especially in the trace analysis. To reduce metal contamination in water, the water needs to be passed through the ion exchange resin column or at least 2 times distillation. Now I want to summary the third video about contamination from reagents. Contamination from reagents can be grouped into mineral acid and ammonia, inorganic solids, organic reagents from reagents, organic solvents from organic solvents. The first is mineral acid and ammonia. Mineral acid. Most of mineral acid contain certain amounts of metals. Extra pure acid contain metals in very low levels. Generally, reagents of this quality have a fairly expensive price. Then ultra pure. Ultra pure contains fairly low metal concentration, but the content of some elements varies from product to product. The last is analytical reagent grade acid. Contains metals as listed in the table. Next is ammonia. Ammonia solution in water placed in a glass bottle will be contaminated with silica, aluminum, calcium, and other elements which may be caused by the attack of alkaline solution on the glass. The second is in anorganic solid. In anorganic solids of reagent quality are usually sufficiently pure to be used directly without pre-purification, but a blank control solution must be prepared. The third is organic reagent. Organic chelating reagents usually contain coordinately bonded metals. These metals are usually derived from solvents or reagents used in the synthesis of ligands. Organic reagents or complexes are usually used in such small quantities that contamination is often neglected. The fourth is organic solvents. Metal content in organic solvents is usually relatively low, which must be watched out for is the presence of other organic compounds dissolved in the solvent, because it usually interferes with the spectrometric determination. For example, CCl4 and CHCl3, if left unchecked, COCl2 will be oxidized, which will interfere with the determination of metals using the Ditizon method. The last is loss of analyte. At the preparation stage, the separation and determination of the analyte can be removed by the sample solution by following factors. First is adsorption, the second is volatilization or evaporation, and the third is co-precipitation or deposition. That's all my summary about 3 video this week. If I made a mistake, I'm sorry for that. Assalamualaikum warahmatullahi wabarakatuh.